we are going to be talking about inverse matrices. This is going hand in hand with yesterday's. Actually, the book considers this all in one lesson. And so I split it up. What we did yesterday is going to be step 1. And then we're going to go further. I am only going to do 2 by 2 matrices that you have to find the inverse of. Other ones I may ask you, is it an inverse? But you will not have to find it. You can find inverse of matrices bigger than that. So, the reason we have inverses is so we can solve equations. So, what is the multiplicative inverse of 3?
9.
Dividing by 3. Or multiplying by a 1/3. So to solve this equation, I could have multiplied both sides by 1/3. Or I could have done 3x divided by 3. That all is the same idea.
Or we could divide by 3.
Yes. But in matrices, there's no way to divide. So we have to use the idea of that 1/3, that multiplying by the reciprocal. Okay? So because there's not this operation with matrices, we have to revert back to the multiplying by the inverse, which is that 1/3. Okay? So, if I give you the problem of -3, 7, 2, 4, and I ask you to find the inverse. There's 2 different ways I can ask you to find the inverse. One is I will write it just like what I did there, where I put in -1 as an exponent. That is the non-written way of saying it. So I could either ask you in directions, find the inverse of the following, or I can give you a -1 as an exponent, and they mean the same thing. Does that make sense? So the way you will do this is you will do 1 over the determinant, and I'm just going to call it DET for determinant because I haven't named that matrix. And so let's go ahead and find the determinant just so we can have that for the next step. So the determinant of this matrix how did we find that yesterday? You did the downs
Minus ups.
minus the
Ups.
ups,
That's a good one.
which is 14. Excuse me. And so that gives us -12 minus 14, which is -26. So our determinant is -26. That's just something you'll do on the side. That's just scratch work that will be done to create it. And so we can replace our determinant with -26. Now, we need to find the inverse, the way the numbers are going to move around. And what's going to happen is these two switch locations. So what I highlighted in yellow are just going to switch locations. The 4 is going to go here, and then negative 3 is going to go here. What I've highlighted in orange is going to change signs. So they stay in their location, their sign just changes. So we have 1 over our determinant times that new rearranged matrix. Did my determinant change anything here? So I would still have a negative 12 minus a positive 14. So my determinant doesn't change when you rearrange it. But now we're going to multiply everything by that fraction in the front. And so our final answer is going to be negative 4 divided by 26. Can 426 reduce? They're both divisible by 2, so that gives us 2 over 13. So all that was reducing. So we're going to do the next step. We have a negative 7 divided by a negative 26. Can that reduce?
No.
Can the negative signs reduce?
Yeah.
So we end up with a positive 7 over a positive 26. For the next one, negative 2 divided by negative 26. Can that reduce?
Yes.
To 1 over 13?
Yes.
And then negative 3 divided by negative 26. Can that reduce?
No. Yes.
The signs?
Signs can.
So leaving you a 3 over 26.
Out of here.
And then we're done. Tonight for the assignment, I'm going to make you identify a single number off of it to color with. And remember, that's your rows and your columns that identify the element. So let's do another one.
Do we have something on Pearson too?
Not tonight.
Just the worksheet. Okay.
So we have negative 7, 4, 5. Oh gosh, not 5. 14 and 8. Negative 8. So let's find a determinant. So I'm just coming down here to scratch work area, and I'm going to do my determinant there. So negative 7, 4, 14, negative 8. My downs, 56. My ups, so downs minus ups results in 0. And so when we're finding the inverse, I forgot to put a negative 1 up here. When we find the inverse, we do 1 over 0. Can I do 1 over 0?
No.
So that means no inverse. So if your determinant is 0, there's no inverse. The inverse does not exist. So when you have a determinant of 0, can you do the inverse? Let's do one more where we actually can find it. And we're going to do the inverse of negative 2, 7, 4, and 5. What do I need to do for step 1?
Find the ups and downs.
Find the ups and downs for the determinant. And so the determinant of negative 2, 7, 4, and 5. So my downs,
-2. -10
my ups,
is 7, 4, 28.
so give me a total of a negative
28.
negative 38. So 1 divided by,
-38.
and then for my matrix,
36.
oh, yes I did. For my matrix, which 2 am I going to switch?
-2 and 5.
Negative 2 and 5. So we're going to switch negative 2 and 5.
And then you're going to switch 7 and 4.
And then 7 and 4 both become negative. In this case, they could be positives or negatives.
Oh, yes.
Based upon the sign, you switch it. And so now we're going to multiply everything by
138.
1/38, a negative 1/38. And so that's going to give me a 5 divided by 38, and it's going to be negative. So a negative 7 divided by a negative 38 can give me a positive 7/38. Now the next 2 are even, so I know that they can reduce. So negative 4 divided by 38.
So they are both divisible by 2. So that would be
2 over 19.
Okay.
And then
What would the negative 2 divided by 38 be?
1 over 19.
And so that's my final answer. That's the inverse. So if I asked you for a 2, what would your answer be?
119.
1/19.